Okay, so in this video, we're going to go over the solutions to homework number 8, which is pretty much the same thing as homework number 7, where we're graphing our basic functions, but with some additional questions. All right, so we'll start these the same way. In the first one, part A, f of x equals 2 times x minus 1 squared minus 2. And with all these basic functions, we've got to get the vertex. For this right here, the inside will be 0 when x is 1, and the constant being subtracted at the end is minus 2. So that's our vertex over 1 and down 2. I'll pick a point near 1, such as 2, substitute it into the function. 2 minus 1 is 1, square root is 1, and 2 minus 2 is 0. And I know that's also going to be the case 1 point to the left because a parabola is symmetric about the axis of symmetry. And there's my parabola. It makes sense. It's concave up. It was shifted to the right 1 unit and dropped down 2. The domain, because it's a polynomial, is all reals. The range is from low to high, so it's from -2 to infinity. It's the lowest y value to the highest. The zeros, I'm just going to set the function equal to 0. I'm going to start by adding 2 and then dividing by 2 to get 1. So be careful, you don't get 0, you get 1. Add 2 and divide by 2. I'll undo the square by plus or minus the square root of the other side, and the square root of 1 is 1. I will then add 1 to the other side, and when I split these up, x equals 1 plus 1 is 2, and -1 plus 1 is 0. And those are my zeros right there. So some good algebra there. The additional questions talk about the behavior of the function. The function f is decreasing when the graph is falling from left to right. So that is from -infinity to the x value of 1. You're not talking about the y values for which it's decreasing. You're talking about the x values for which it's decreasing. The function's increasing from right to left from 1 to infinity. This is from when x is 1 to infinity that it's increasing. Because the graph is concave up on this parabola, the y value will represent a minimum. The minimum value is a y value, and that minimum value is right here, -2. It has no maximum because the graph keeps extending to infinity. That's number 1. Part B, f of x equals 1 minus the absolute value of x minus 3. So what I may want to do is rewrite this so that the negative is in front. And we've talked about our parent functions, quite a bit. And this is the parent function of the absolute value of x. The x minus 3 is going to shift it to the right 3 units. But that negative in front is going to flip it upside down and reflect it about the axis. And that plus 1 is going to drag it up. That's kind of what my graph should look like when it's all over. So the vertex is that first step again. And what makes this 0 for x is 3. And the y value hanging out there is 1. So as we expect, we're going to go over 3 units and up 1, just like our transformations confirmed. I'll pick a value near 3, such as 4. I'll substitute this in, and 4 minus 3 is 1, and its absolute value is 1, times a -1 out here in front is -1 plus 1 is 0. So it's 4, 0. And another point to the left will be the same output, because again, absolute values are symmetrical. So now I'm not surprised that my absolute value is flipped upside down because of the negative leading coefficient in front. The domain is all reals again, -infinity to infinity. The range, though, is a little different. It's from -infinity up to 1 with the bracket. It goes from low to high. The zeros, just some good algebra. I'm just going to set this equal to 0. I'm going to subtract this 1 over, if I can keep my screen stable there. And then I'll divide out the negative on each side. The absolute value equals plus or minus 1. So x minus 3 equals 1. or x minus 3 equals negative 1. I'll add the 3 to get 4, add the 3 to get 2, and it's by no surprise I see my zeros here are 2 and 4. To answer the questions where the function's increasing, where is the graph rising from left to right? From negative infinity up to when x is 3. My graph is decreasing from when x is 3 to infinity. And I have a high value, and that maximum value is up here at 1. Remember, maxes and mins are the y values. They're the output, not the input. In part C, I am presented with a square root function. And, just again, think about our parent function square root. On the inside, I'm going to slide to the right 1 unit and then multiply it by a factor of 2 so it gets even steeper. And then I'm going to drop this down 4, and that's what my graph should look like in the end. All right, what's the vertex? What makes that 0 for x is 1, and that constant hanging out there is negative 4. So I'm going to go over here, just as I suspect, and down 4 units. I'm going to pick 2, put that in for x, and I think we should all, get that pretty easily. 2 minus 1 is 1. Its square root is 1, times 2 is 2, and 2 minus 4 is negative 2. So I'm going to go over 2, down 2. And another good x value to pick, I guess, is 5, because 5 minus 1 is 4. Its square root is 2, times 2 is 4, minus 4 is 0. So 3, 4, 5. And I conveniently also have a 0 of the function. The domain is not all reals. It starts at an x value of 1 and goes to the right to infinity. The range has a low y value of negative 4, but it goes off to infinity. The zeros of the function, just some good old-fashioned algebra here. I'm just going to add 4 and then divide by 2 to get 2. But I'm going to undo that square root by squaring both sides. And boom, right there is my x-intercept. This function is only ever increasing, and it increases from when x is 1 to infinity. We do have a minimum value here. We have the lowest y value achieved over here, which is negative 4. In D, I have a pretty basic function for x squared, and it's 4x squared minus 4. The vertex, well, there is no horizontal shift, so the x squared is going to keep it right there. I'll times it by 4, so things are going to get steeper, and then I'm going to drop it down 4. The vertex here, what makes this 0 for x is 0, and the output is negative 4. So my vertex is, 0, negative 4. I'm going to pick x as 1, and obviously I get 0. If x is negative 1, I will get 0. It's a concave up looking parabola because leading coefficient is positive. The domain, because it's a polynomial, is all reals. The range is from negative 4 to infinity. The low y value to the high is negative 4 to infinity. The zeros, again, I have them, but to do the algebra, I add 4, divide by 4 to get 1. And you undo that square by plus or minus its square root, which is 1. See right here, that's good connection graphically. That where the graph hits the x-axis, that's where my zeros are, as well as the x-intercepts. My function here, the graph is decreasing from negative infinity to, not negative 1, but 0. It's the x's for which the graph is falling. My graph is increasing from when x is 0 to infinity. I do have a low y value here, which is a minimum of negative 4. And in E, as a basic function, f of x equals 2 minus root of x, and we should rewrite that as negative root of x plus 2. So the leading coefficient is negative and is in front. If I think about my parent functions again, this is my square root function, check mark. The negative in front will reflect it, check mark, and I'm going to raise everything up too. So it's going to look like this, that final looking graph. The vertex will be 0, 2. What makes that 0 for x is 0. And this constant hanging out here is a 2. Yeah, once you get the vertex, you're good to go. 0, 2. And if I pick 1, I can't pick a negative because I can't take the square root of a negative. So the square root of 1 is 1, and minus 1 plus 2 is 1. Then if I pick, say, 4, put that in. The square root of 4 is 2, and then times that negative 1 is negative 2, plus 2 is 0. So 4, 0. So this I should label here, I guess, as 1, 2, 3, 4, 0. Gives me more of a direction from left to right. And that's the shape of it. And sometimes students will connect it like this. That's where you want to use knowledge of your transformations as of, the shape in the end that the graph should look like. The domain is not all reals. It's a square root function. We worry about when the inside is negative. So it's from when x is 0 to positive infinity. The range is from low to high. It's going to go from negative infinity to a high y value of 2. And that also means the maximum y value is 2, and there is no min. My function here is strictly decreasing throughout the entire domain, so it's decreasing from when x is 0 to infinity. And the last graph is part f. F of x equals 2 times the absolute value of x minus 2. Again, let's take it down to our parent function, which is this. I'm going to times those by 2, so it's going to get a little steeper. And then that minus 2 is going to drop it down by 2. So it looks like that. That vertex is 0, negative 2. And I'm just going to come over here. The origin down 2. Pick x as 1. Pretty easy. And the absolute value of 1 is 1, and 2 minus 2 is 0. And if I pick negative 1, I'll also get 0. And there's my basic graph there. The domain, once again, is all reals. It's not a polynomial, but I won't get any 0 in the denominator, nor a square root of a negative, obviously. The range, what's the low y value, is negative 2 to infinity. The zeros, well, that's pretty obvious, but algebraically, just to practice your algebra, add 2, divide by 2, sloppy there, and then x equals plus or minus 1. And notice, that's where those zeros hit, those x-intercepts. This function is decreasing from negative infinity to when x is 0, and it's increasing from 0 to infinity. We do have a minimum y value, which is negative 2. That takes care of that part. And part 2 is old stuff about the new coordinates. So here A has the coordinates negative 6, negative 2. B has the coordinates negative 4, 0. C has the coordinates 0, 2. D has the coordinates 2, 4. And E has the coordinates 4, 6. And f of x equals 3 times g of x minus 2. What will be the new coordinates? So x, there's no change on the x because nothing's changing on the inside. So the x's will stay the same. The y's, I will multiply by 3 and then subtract 2. So keeping the x's the same for a, I'll have just keeping the x the same for a is negative 6. But negative 2 times 3 is negative 6, minus 2 is minus 8. In b, keeping the x the same, 0 times 3 is 0, minus 2 is a minus 2. For c, 0 times 3 is 0, and then, keeping the x the same, 2 times 3 is 6, minus 2 is 4. Keeping the x the same, 4 times 3 is 12, minus 2 is 10. And for e, 4 times 3 is 12. No, I'm keeping the x the same. Why do I keep doing that? 6 times 3 is 18, minus 2 is 16. And then in part B, that's the solution to part A. In part B, we have that f of x equals 1/2 times g of 2 times x minus 4. plus 4. So quite a bit going on here. So for the x's, I'm going to start on the inside and do the inverse. So instead of multiplying the x's by 2, I'm going to divide them by 2 or times it by 1/2. But then I'm going to add 4. For the y's, I'm going to multiply the y's by 1/2 this time. And then I'm going to add 4 to that. So to shrink things down a little bit, for the a's, -6 divided by 2 is -3, plus 4 is 1. For b, -4 divided by 2 is -2, plus 4 is 2. And c, 0 divided by 2 is 0, plus 4 is 4. I just want to make sure I have that right from before. -2 plus them, yeah, that's okay. And then d, 2 divided by 2 is 1, plus 4 is 5. And for e, 4 divided by 2 is 2, plus 4 is 6. The y's, I'm going to multiply by 1/2. So -2 times 1/2 is -1, plus 4 is 3. And for the second one, 0 times 1/2 is 0, plus 4 is 4. And then 2 times 1/2 is 1, plus 4 is 5. And then for this one, 2 times 1/2 is 1, plus 4 is 5. And for E, 6 times 1/2 is, right here, 6 times 1/2 is 3, plus 4 is 7. Getting lost here where my coordinates are. I just want to make sure that A is right. So -2 times 1/2 is -1, plus 4 is 3. And then 0 times 1/2 is 0, plus 4 is 4. And then 2 times 1/2 is 1, plus 4 is 5. And then 4 times 1/2 is 2. I knew something was wrong there. Plus 4 is 6. So that does need to be corrected there. So 4 times 1/2 is 2, plus 4 is 6. I knew something was off. All right, and the very last question, number 3, finding the equation of a line. For a line, I always need a slope and a point. My point is -3, -4. But to be perpendicular to this line, which is in the form of mx plus b, this slope is 4. I need its negative reciprocal, which is -1/4. So there's my slope. And my setup will be y minus the -4 over x minus the -3 equals -1/4. And don't put the backslash like I did, because it gets confusing where the x is at. These will all become a positive. Cross multiply. Pretty easy algebra there. So 4y plus 16 equals x plus 3. Subtract 16 and get x minus 13. And y equals 1/4 x minus 13 over 4. And that concludes the solutions to this homework number 8.